Hi guys, Levi here from Bright Young Brains. In this video, we are going through the entire maths grade 12 2022 November final year exam, going through all the questions without leaving anything out. As you can see here, there's algebra, sequences and series, and then we're obviously going to move on to, sequences and series next, more sequences and series, the functions question over here. There's usually about 3 functions questions. We can say 4, including things like calculus, straight line graphs there that look like inverse. And then what we have here, this is financial mathematics for grade 12 learners. And then there's obviously applications of calculus in addition to there's applications of calculus in addition to calculus in itself. And then here we have first principles, what we have down here, probability, going on and on and on. And then here we also have, what do we also have here? Yeah, more probability, and then the fundamental accounting principle. So yeah, that's what we're gonna do in this paper, starting from the top here. So let us go. The timestamps are in the description. So if you wanna jump straight to a specific question, you can just use stamps in the description. Let us begin. It says here we should solve for x. So solving for x, it's really not an issue because like solving for x is like straightforward and direct. So solving for x, the one thing we can already remember here is obviously since this is already properly factorized, we're just going to make the first bracket equal to 0. So the first bracket equal to 0, minus 6 equal to 0. Let's see, positive 6. So the one thing I need to do is to make sure I don't make silly mistakes. But if I do make a silly mistake, you forgive the boy. Forgive the boy, for the boy is not a robot. Robot boy. Anyways, so 1.1.2 says we need to solve for x here without using a calculator. Oh no, we have to use a calculator here. Since they said it has to be to 2 decimal places, you have to use the quadratic formula. So this is minus b plus or minus b squared minus 4ac, the whole thing over 2a, right? So all this in the calculator, let's see what we're gonna get. The b value is -6. So this is like -6 squared minus 4. Our a value is 2, c value is like 1, and then this is like 2a, right? So all this being done, right? Let's see what we can get if we put all this in the calculator. Putting all this into the calculator, let's see, minus -6 plus -6 squared minus 4 with 2 and like 1 here, the whole thing over 2 times 2. So this is giving us 2.8 what? 2.82. That's the first answer. The other one, where we put a negative here, is because you see the plus minus, obviously we have to just do one of them at a time. See, this one is giving us 0.18. There we go. Nothing crazy, nothing major. Let's just double check if you put everything in the calculator nicely there. Looks like we did. Yeah, man, looks like we did. So let's move on. The next one says 1.1.3. So for x, solving for x, you have to put everything on one side first, so that you can see what kind of a quadratic equation you're dealing with. It's a basic quadratic equation that is a smiling face. So the one thing you want to do with these questions is draw out a rough idea of the sketch. It's a smiling parabola. Secondly, it has, this looks like it will have 2x intercept. We just don't know where. This is asking us where is the graph having y values that are bigger than 0. You see, this is asking where are the y values of the graph bigger than 0. Because technically the equation of the graph, you can almost imagine the equation is y is equal to x squared minus x minus 90, you see? So this is asking where is that equation having y values that are above 0. So we know it's having y values that are above 0 over here, you see, and over here, you see. So that means starting from here, going to the left, starting from here, going to the right. you see. So all things considered, right? All things considered, we have to get our x-intercepts first. So getting the x-intercepts, you can just use the quadratic formula, or you can just maybe get factors of 90 that give you a 1, you see. So factors of 90 that give you a 1, yeah, we might not get that very easily. So let's just see. Let's just think. Factors of 90 that give us a 1. Bro, it feels like we're gonna probably check forever, but let's just try. 90 and 1 don't give us a 1. 45 and 2 don't give us a 1. Because we said you should get factors of 90 that give you the number here. So let's see. Does 3? Yes. 3 and 30? No, doesn't work. Does 4 go into 90? No. 5? 5 going to 90? How many times now? Yeah, 90 divided by 5. That's like 18. Nope, doesn't work. Does 6 go into 9? Yeah, 15 times, but doesn't work. That does not give you a 1. 7 does not. 8 definitely doesn't. 9 and 10. Ooh, okay. Ha ha ha. Bingo, bingo, bingo. 9 and 10 give us a 1. So you could think to yourself, okay, fine, we can factorize this, right? Let's see. 9 and 10 give us a 1. So it's like you can put 9 here, 10 here. But to get a minus 1, it has to be minus 10 plus 9, you see. There you go. So you're solving for x first because you want to get the x-intercepts. This is going to give you x is equal to negative 9 or x is equal to plus 10, you see. So what you now know is this left side here, there's a negative 9. This right side, there's a positive 10. So your answers, you're going to say that the answers of x, right, that satisfy this initial equation or this initial inequality, your x values need to be below negative 9, or those x values need to be above positive 10. This is how you're going to give this answer. Most of the time, people like to say x is an element of like negative infinity up until negative 9, or x is an element of positive 10 up until positive infinity. So you can give your answer like this here, which is what most people like to do, or like this, which is also what a group of people also like to do. So you just do what you feel you want to do. Depending on how you give your answer, these will be both 100% correct. So the reason why we're not putting smaller or equal to or bigger or equal to here is because there's no extra line over there, you see. That's why you also have round brackets over here and round brackets over there. For infinity, either negative or plus, you always just put round brackets. Let's move on. 1.1.4. So depending on, this is just the algebra section, right? But there is an algebra course on our website. Ooh, courses. Bro, that's not how you spell courses. It's courses. Wait, is that how you spell courses? Whoa, bro. Thank goodness it's a maths website. So for the online courses on our website, right? I mean, there is a algebra course, full algebra course. The link for that is in the description. But anyways, let's see here. It says we have to solve for x. We're still solving for x. So the idea is anytime you're gonna see this square root symbol, you wanna isolate the term that has that square root symbol. So we might as well just have here negative 7 square root of x. Everything goes to the left, right? Or rather, like let's deal with positive numbers. So let's keep the x here, move the 10 to the 12, move this whole thing here to the left side. It becomes a negative, right? However, I mean, it becomes a plus. So from here, you want to square this side here, and then you want to square this side. The reason for doing this is we're trying to get rid of the square root symbol, because doing calculations with that square root symbol, it's not the best. So here you can say 7 squared is like 49. Square root of x squared is like going to give you x. And then here you have to say 2 brackets, both with x plus 12. You see, don't make the mistake of saying x squared and 12 squared. That's not correct. It would only be x squared and 12 squared if these things were being multiplied together. So here, x times x is x squared, and then plus 12x, and then another 12x. 12 times 12 is 144. This comes over, it's like 49x. So the big idea is, if you do find a small error, I mean, in these calculations, depending on what I'm doing, you can just add it in the comments, you know, because I mean, small errors are definitely inevitable. So 12 plus 12 minus 49, because those are like terms, it's going to give us a negative 25. Negative 25x plus 144. So you want factors of 144 that give a 25. That one's gonna be tricky, like proper tricky, like seriously, like yeah. But for the kind of a question we're getting, us getting what you call answers that are like a bit weird, we should be expecting that, because I mean, like, there is a square root there after all. So factors of 144 that can give us a 25. Well, I was thinking of 24, 12 and 12. 12 and 12 give us a 24. But then the next best thing you could be thinking to yourself, I mean, what? I mean, that's not, let's just see from the bottom. Maybe we might get something. 1 and 144 don't give us 25. 2 and what? 144 divided by 2, that's 72. This won't work. Does 3 going to 144? I don't know. Let's find out. Yes, it goes in 48 times, but 48 and 3 don't make a 25. So let's keep checking. You see, 4 and 36, nope, don't work. 5 won't go in there. 6 and 24, definitely not gonna make it 25. And then the next number, 18 and 8. Oh, we might be lucky. Are we? 18 plus 8, 26. Oops, dude, so close, but yet so far. Like, what a wow, bro. Like, what a wow. 16 and 9. Wow, why is this thing also giving us, oh, boom, 16 and 9. So we can do 16 and 9. You see, 16 and 9. To get a minus 25, it has to be minus 19 minus 16. And then we have to solve for x. X here is a 9. X here is a 16. Well, no, now the thing is, you want to test out both answers. Do they balance out the equation? Well, let's see. 9 minus 7 square root of 9 is equal to negative 12. Okay, let's try the 16 minus square root of 7 with, yeah, they both work out. So this is all good. That's why this is just easy 4 marks. Let's keep things moving. 1.2 here, they're asking us to get x and y simultaneously. So to get x and y simultaneously, I mean, this one seems quite straightforward. We can isolate y over here. Seems like the easiest one to isolate. And then we can throw it in the second equation. So here we can have 2x. The 2 goes to the other side, becomes a negative. The y is on its own. You see? Label this equation number 2. So this equation, we're going to throw it in there. You see, so it's going to be x. Wherever you see y, put this whole thing here. 2x minus 2. This is equal to 4. And then let's solve for x. This one was quite a simple, straightforward, what you call, solve for x and y equation. So here we took the 4 to the left, multiplied inside the brackets. Now, in a situation like this, I mean, you can take out a 2 as a common factor. X squared minus x minus 2 equal to 0. Divide everything by 2. Let's see what you're going to get here. X squared minus x minus 2 equal to 0. Now, in this kind of situation, you could just then factors of 2 that give a 1. It's like 2 and 1. You see, 2 and 1. To get a minus 1, it has to be minus 2 plus 1. And then here, x is a positive 2 or x is a negative 1. Now, these are the kinds of questions where you definitely always want to double check your answers. So, I mean, let's just get x. We got x here, let's get y now. And then we test it out if they both balance out the equation. So here, x is a 2. It means y is also going to be a 2 if you divide both sides by 2. And then here, x is a negative 1. So it's like negative 1, therefore, no, bro. Come on, man. Come on, bro. The y, the y here is what? You're getting y, right? So x is negative 1. And then here you divide negative 1 on both sides. Your y value is going to be negative 4. Okay, so don't make the mistake of not testing out your answers, you see. You have to test out your answers. So testing out your answers, what are you going to do here? This is, let's see, positive 2 and positive 2 for y. Yeah, 2 times 2 give a 4. And then here, I mean, let's test it in the other equation. If the 2 is a 2, is a 4, if your x is a 2 here and the y is a 2, it's going to be 4 minus 2, which is a 2. Yeah, this is very simple. Hence the 5 marks. So yeah, this question is all good. It's working out. So you can do those kinds of things in an exam to test out your answers. It will boost your confidence. Okay, so with question 1.3, it says here, show that 2 times 5 to the power of n minus 5 to the power of n plus 1 plus 5n plus 2 is even for all positive integers, or rather for all positive integers, yeah, for all positive integer values of n. So fortunately, this is really not a difficult question. Fortunately, it's out of 3 also. So the first thing that we can already spot is that for each term here, there is at least 5 to the power of n. So what you can do for yourself, firstly, just to make things a bit clearer, right? Let's just rewrite this like this. This, we can write it as 5 to the power of n, and then 5 to the power of 1. And then here, this, we can write it as 5 to the power of n, and then 5 to the power of 2. So here we can take out 5 to the power of n as a common factor in all these terms. We're going to be left with 2 minus 5 plus 5 squared is like 25. And then let's see here, this is going to be 25 minus 5, which is 20, plus 2, which is 22. And then here you have 5 to the power of n multiplied by 22. So 22 is obviously an even number. And then 5 to the power of anything will always come out as an odd number. Now, what we all know, or what you should know, is that an odd number multiplied by an even number will always give you an even number. You see, that's just mathematics in its simplicity. So with that being said, here you can then just conclude by saying, therefore, let's say here, therefore, the expression, you don't even have to write this therefore, but just for the vibes, let's do it. Therefore, the expression is even for all positive integer values of n. See, and then we can move on to the next question. 1.4. So let me just show you something. You see, as I'm starting with 1.4, I'd actually skipped 1.3, you see, but obviously since you're watching the video, you saw when I had already like figured out 1.3, but while recording, I also do the same thing. If the question seems a bit crazy, it's easier to just move on and come back to it later, you know? But anyways, 1.4 says, determine the values of x and y if this equation is equal to the left. If this equation, if the right side is equal to the left side, you have to determine the value of x and y. The mark allocation here is our consolation because it's not so much. It's just, what is this? 4 marks? So what I'm trying to say is, based on the nature of how this question is asked, 4 marks for a question like this doesn't seem so bad because it's 2 variables at the end of the day. So we don't have to do too many things. So to start off, I don't think mixing these 2 sides is going to help us much. I don't think so. But let's try and find some middle ground, you see? So what you can do is, firstly, this number is not a, wow. There's an invisible 2 here. I don't know if that's, excuse me, why am I even yawning? This is literally in the middle of the day. I'm busy yawning here. It's like 2:20 something as I'm recording this. But anyways, let's see. The strategy with a question like this is, firstly, mixing both sides may not be very ideal. If push comes to shove, we could mix, but let's see. 3 to the power of y plus 1. We can write it like this. The bottom part here is 32. The right hand side, let's see, this tiny 2, let's just leave it for now. Maybe the issue is the exponent being x here. Yeah, that seems like it's gonna hammer us a bit, so we have to find a way to not deal with that x the way it is. So what I can suggest is, for this right hand side, right, let's maybe take the 2 and put it under the x there. So we're gonna have 96 with x over 2. And then what we can actually do is, what you can see is the x can be written as an exponent, you see, like this. I'm trying to show you that the x is what's kind of stopping us from really like seeing what we're dealing with here. So we can write it like this, you see, because a half times x is the same as x over 2 here, because you see, x times a half gives you this value up there. So we wrote it like this because it's, mathematically speaking, this is something we can like look at nicely and we can work with and all that. Anything to the power of half, we know it's a value under a square root. So fortunately, we now know that from here you can automatically just go from here to that. It's valid. We have just shown steps of its validity. So this makes life a bit easier. We'll deal with the right for now. Let's just see how far we can get. So here, it's not a square number, but what you do is you split it up into two numbers. One a square number, one not a square number. So it looks like here, let's just see. Factors of, let's see 96, factors of 96, right? In your calculator, you can press 96 equals and then shift fact. I mean, you want to split it up into one number that's a square number, one number that is not a square number. So let's see, factors of 96. 1 and 96, none of these are square numbers. I mean, one is technically a square number, but let's see. There's 2 divided by 96 divided by 2. You have 2 and 48. None of these are square numbers. Let's try 3. 3 and 32. Ooh, okay. We kind of have something here because there's a 3 and a 32 here. Wow, tempting. Yeah, this is very tempting. I don't even want to lie. We might as well go for it. Let's go for 3 and 32. Let's abandon ship and go for 3 and 32 without wanting to. Let's just go for 3 and 32. The reason I'm going for 3 and 32 is because I see there's a 3 and a 32 on this side also. We might be lucky somewhere, somehow. I know we're looking for something else. We're looking for something that where we have a square number and something that is not a square number. But in the process of doing that, so that we don't just sit doing nothing, we have found that, okay, 3 and 32 give a 96. So that might be more useful to us. Let's just see here. Square root of 3 times 32, the whole thing to the power of x, right? We can actually even go back to this step, right? Oh, no, let's stay where we are, because this can be written as 3 to the power of a half, 32 to the power of a half, the whole thing to the power of x, which we can even say 3 to the power of x over 2, 32 to the power of x over 2. That's as far as we can get here. On this side, it looks like we're going to go somewhere similar to that, one way or the other. It looks like what we can do here is, if you're going to put everything this side into one line, the 32 can go up. Remember, it has an exponent of 1. The 32 can go up here, and its exponent is going to be a negative 1. So here we're going to have 3 to the power of y, 3 to the power of 1, 32 to the power of negative 1. So for these two sides to match, right? For these two sides to match, firstly, the 32 to the power of negative 1 goes with the 32 to the power of x over 2. Those definitely go together. These two, we might as well just have them with one base, because, I mean, like, it looks like what we were doing there, it did not work out. So this is what you can keep in mind, the fact that always be ready to adjust what you wrote. So we're going to work this out by inspection. It looks like 32 to the power of negative 1 goes with 32 x over 2. So here the exponents have to match, right, because the bases are the same. So negative 1 is equal to x over 2. Multiply both sides by 2 to get x on its own. We're going to get x here as negative 2. Since x is -2, I mean, here we can say 3y plus 1 is equal to 3x over 2. We got x as -2 there, so this is 3 -2 over 2, 3y plus 1. This is like 3 -1 over there, y plus 1. Bases are the same, so we drop them, work with the exponents. The one goes to the other side is -2. Great, 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 great. So yeah, that is all good. Obviously, don't forget to test your answers because you're not that, don't be that arrogant. So fraction button, y to the power of -3 to the power of -2, and then plus 1 over there, the whole thing over 32, right? No, the whole thing on top of 32. This is giving us 1 over 96. On the other side, let's put our x as -2. It's also 1 over 96. So both, this is 100% correct. So all questions where you can check your answer, there's no excuse to get it wrong because you didn't check, you see. So always just check so that you can always correct what you need to correct. Whew. Anyways, so let's move on to question number 2. Question number 2 says the first term of a geometric series is 14. The sixth term is 448. So this is the kind of a question where you need to know how a geometric series is laid out. Because if they say term number 1, right, that's T1. And this is term number 6. Wow. T1, T2, T3, T4, T5, and T6. So when you visualize what they're talking about, it's easier. Term number 1 is just going to be, they say the first term of geometric series is 14, the sixth term is this much. So the idea is what you do is, remember, T1 is represented by A. T2 is A times R, and then A times R squared, A times R to the power of 3, A times R to the power of 4, A times R to the power of 5, going on and on and on. What we do know is that the first term is a 14, you see. It means that this becomes 14R, 14R squared, 14R cubed, 14R to the power of 4. This we could have written there 14R to the power of 5, but we actually have an actual value for the sixth term, which is 448. So what I've just done right now, you see, you being able to lay out a question nicely like this. These are the kinds of things you learn on the online courses, you see, because there's a full sequences and series course where you will learn things like what I'm showcasing down here, you see. The link to that is in the description. But then anyways, carrying on from here, what we already know is that T1 we are given, T6 we are given, we're supposed to work out R. So in this situation, right, what you can actually just do is use this scenario here. You know that AR to the power of 5 is equal to 448. The A you have, it's a 14. So you can just work out R from here, you see. Divide both sides by the 14. What do you get? 448 divided by 14. 448 divided by 14. That's like 32. 32. And then what you have? Shift square root symbol, right? So shift square root is the 5 and the 5 here. So here what you get, that's going to be a 2. Yeah, it's going to be a 2. Shift with the square root symbol, you put a 5 on the tiny 3, and then you're going to get a 2. Because what you call, what is the reason? 2 to the power 5 is 32. That's how you get a value of R. Nothing crazy, nothing major. Let's keep on moving. 2.1.2 says determine the number of consecutive terms that must be added to the first 6 terms of the series in order to attain 114,674. We have to read that again. Determine the number of consecutive terms that must be added to the first 6 terms in the series in order to attain this. So all you do is just work out how many terms need to be added for you to get this. And then once you get how many terms need to be added to get this, all you do is you're going to say, say our answer here is like, I don't know, 50, right? No, that's too much. Say our answer here is like 16. You see, say the 16 terms, say maybe the sum of the first 16 terms is what you call 114,000, whatever. What you'll then do is you'll just say that you have to add 10 terms to the first 6 terms to get 114,674. That's how you answer a question like this. You see, you don't want to overthink it. You just want to think simple. That's what you're gonna do. It says here, right? With all that being said, let's see what we can do. So let's work out the sum of the first. Let's work out how many terms we need to add it up to get this value. Since it's a geometric series, we can use this formula: a rn minus 1 r minus 1. Excuse me. A and r we have, and we have Sn already. 114,674. A here. Well, actually, let me just take a detour. Let me isolate n. So isolating n, we can multiply both sides by the denominator, and then we're gonna have Sn r minus 1. These cancel out, then you have a rn minus 1. And then we can divide both sides by a, Sn r minus 1 over a. And then we can just take the negative 1 to the other side, Sn r minus 1 over a plus 1. Since we want to isolate n, right, we can use logs. So n is going to be isolated, then you're going to have log. The base of the exponent is r, so that's the base of the log. And then this whole value here, it's going to be here, the way it is. Let's see here, the whole thing over a plus 1. There we go. So let's put the numbers in the calculator and then just get an answer. So this is like log, our value of r is like, what did we get again? What did we get for r? 2. We got a 2. And then, well, actually, we didn't even test our answer. We can test it, actually. We can test it by just putting 14 times 2 to the power 5. Let's see if we get 448, you see. Or you can just start with 14, right? And then you just say times 2. That gives us this value, times 2. That would give us this one, times 2, this one, times 2, this one, times 2, this one. Yeah, it works out. Anyways, let's see here. Let's put in our values. Let's carry on. R is a 2. Sn, we said it's like 114. And then what? 674. 674. R is a 2 with 2 minus 1 here. A is a 2. And then we have plus 1 here. Then you have n. So let's put in the calculator. Log 2, fraction button, 114,674. Inside the brackets, 2 minus 1. And then under the fraction, you have a 2 there. This is giving us 15.81. However, you cannot be adding up what you call 15.8 something terms. You can only add up like full values, you see, or 1, 2, 3, or 5 terms going on and on and on. So since we're seeing that you have to add up 15 point something terms to get this amount, technically speaking, you would need to have added up 16 terms. Wow, this is such a coincidence. I promise you, it's such a big coincidence that the value here is 16. When I guessed 16, it was literally like from the top of my head, like I kid you not. So here, since we're seeing that we would need to add up like 16 terms, right? 16 terms, let's just say 16 terms. Let me write it out as a paragraph while explaining, you see. 16 terms need to be added to get at least 114,674. Therefore, 10 consecutive terms need to be added to the first 6 terms to get 114674. There we go. There we go. It's all nice, it's all dandy. Anyways, let's move on to 2.1.3. 2.1.3 says, well, we have to test it out also, you see, because I mean, like the way everything has been put in this calculator, we have to test it out, you see. Fraction button, A is what? A was a 14, was it not? Yeah, 14. And then we have 2 to the power of, let's just say, let's try 15.81, see if we're going to get this answer that we had gotten here. Minus 1, the whole thing over r minus 1. Nope, it's not working out. Yeah, we definitely made a mistake somewhere. Yeah, that's why checking your answers is very important, because this is giving us something else, something totally wrong. But let's see what I did here. Times both sides by this thing here, divided by a, moved the 1 over, and then we did shift square root whatever. Like seriously, it's not working out, bro. It's too big. Yeah, I think I made a mistake somewhere. So I think for the sake of doing better, in my own opinion, right? Actually, this method here, I normally use it for financial maths, you know, where you isolate the variable first, because that's where they normally want you to not round off. But here, the answers that we're going to be getting here before the final answer, they're not, the chances that they're going to have like decimals that are just lingering, the chances are very low, you see. So let's just work this out nicely. See, 114,674 equal to 14, unless I put that, let's just carry on, n minus 1 here, 2 minus 1. 2 minus 1 here is a 1. So you have here 14, like that, because this is just a 1 at the bottom there. And then what's next? You're now going to divide both sides by 14, right? Divide by 14, divide by 14. So let's see, 114,674 divided by 14. That's like 8191. 8191, these go away. And then the 1 goes to the left, you add, so 8192. Now this, you want to do your log thing. Log, the base is a 2, the value here is 8192, n is n. Wow, I feel like I don't know what weird silly mistake I did in the previous question, but 13 is the answer, my bro. So n is equal to 13. So here you can say 13 terms, right, need to be added to get at least this value. Therefore, let's see, from 6, 7, 8, 9, 10, 11, 12, 13. Therefore, 7 consecutive terms need to be added to the first 6 terms to get 114,674. So let us move on to 2.3. 2.1.3, right? What does it say? If the first term of another series is 448 and the 6th term is 14, calculate the sum to infinity of the new series. Well, this is just a series going backwards, you see, because it's like 448. Obviously, if you keep dividing by 2 6 times, you end up at 14, because this first one, excuse me, starting at 14, if you keep multiplying by 2, you end up here for the 6th term. So if you go backwards, it's the same idea. So T1 is this value, T6 is 14. Automatically, it means that your value of R is just a half. You see, that's the logic here, because you're just multiplying by half. You're just dividing by 2, dividing by 2, dividing by 2. The logic behind it is you can do the same thing that we did, but you see, this is just A, and then you have like A to the power of 1, and then A to the power of 2, going on and on and on until A to the power of 6. So since you want to work out R here, if you want to work out R, you can use what we did over here, you see, because the main question is asking us to get the sum to infinity. So you would have started off by saying, okay, the sum to infinity, our formula for sum to infinity is just this formula that's on your formula sheet. 1 over, no, it's A over 1 minus R. So we have A already. We need R, you see. You work out R the same way. So here you know that the 14 is equal to the AR to the power of 6. A, we have it as 448. That's the first term. And then R here, you would have just worked it out, you see. You would have divided both sides by 14 here first. You get a 1, you see. 448 divided by 14, that's like 32. So you get like a 32 here. That's like R to the power of 6. And then you're going to divide both sides by 32. 32, 1 over 32, R to the power of 6. Cube root here, with, no, square root with a 6, square root with a 6. What do we get here? I feel like I made a mistake. Hopefully I didn't. Yes, I did. This is supposed to be a 5. Yeah, something was not adding up. This is supposed to be a 5. Because it's like 1, 2, term number, this is like T2, right? And then T3, you see, 2, and then there's a 3. So here there's be a 5. Because this is term number 6, you see. That was the error. Let me just fix it here. Because that's the reason why we're getting that 35 here. 5, 5, 5, and 5. So if things are not working out, don't just leave it. Don't just also cry and be like, oh, it's wrong. No, just double check what you did wrong. In the calculator here, you're going to get a half. R is a half. So the sum to infinity is going to be, how do I write my infinity symbols now? Writing infinity is quite hard, eh? Like, wow. Anyways, A is 14. R is a half. And then we have here 14 divided by a half. That's like 28. Is it? No, bro, that's so wrong, bro. This answer looks, oh my goodness. A is a 448, bro. Come on, man. Come on, bro. Don't be like that. 448 divided by a half. It's going to be 896. Whew. Yeah. So, wow, it's okay. Everything looks fine now. Let's move on. 2.2 says, if this expression is equal to this number, determine the value of k. Well, in my opinion, remember, the idea is, the one thing I've always said, if you have watched most of these videos and if you are subscribed to the online courses, if you've signed up for the online courses, you have to remember that the explanations in there, they're a bit deeper than what you're going to see here on YouTube. For example, any scenario like this is telling you that you're working with a sigma expression or sigma expressions. You have a formula here. You have the terms that you're adding up, right? Starting from a specific position, ending up at a specific position. All those terms added up, they give you this, which is the Sn, you see. So in this situation, all we want to do is, anytime you're given sigma, like this, 99.99% of the time, you're either working with an arithmetic sequence or a geometric sequence. As long as your variable here is not an exponent, you see. Variable is not an exponent. You see, if it's not an exponent, it means that your sequence is arithmetic, you see. ... sequence is arithmetic. So the reason why that's important is you just have to keep in mind that this is just an equation given. The Sn is this number. The other side, it's no. You have to keep in mind that this is the number of Sn, right? This is the value for Sn. This is supposed to give you all the pieces of information that you're gonna put into your Sn formula. Because remember, your variable is not an exponent, so it means that you're dealing with an arithmetic sequence. The moment you know you're dealing with an arithmetic sequence, what you do is you write out the SN formula for an arithmetic sequence, you see, which is on your formula sheet. After writing out this formula, you want to now go and check each of these boxes and put in values. Sn you have, it's 20 and 1/6. You may be better off putting that value as what you call is a mixed, no, as an improper fraction. Okay, so from here, the one thing you want to keep in mind is you have to figure out all these other values, right? So for n, this you may want to put it as an improper fraction. So it's like 20 times 6, which is like what, 120, plus 1, which is 121/6. There we go. So the idea is, with all this being said, right, we need to now get a value for n, etc., and x, etc., etc., etc. Let's see here. I asked that question just now. So to get a value of n, right, this is where you have to be careful. N, you always say the end minus the start, and then you always add 1. You see, just try and remember this formula for cases where your starting is weird like this, you see. So here you're going to say your end value is the ending, which is written as k over there. Wow, this is going to be awkward. We didn't even see the question. The question is, oh, this determine value of k. K minus 0 plus 1, right? Now this is giving us k plus 1. That's the value of n. Interesting. So this is very important. All this being said, let's see here. All this being said, right, we need to now get a value of d and all that. So getting a value of d, what you may want to do is you want to work out like the first two terms. Remember, d is equal to t2 minus t1. So while you're working out d, you can get t1, which is your value of a, which is the first term, and then we'll have everything for our formula, because now we have Sn, we have n. Let's get d, but to get d we have to get t1 first. Remember, t1 is what you get when you put, like, you can put a 1 over there. See, 1/3 with the 1 there, 1/6. You see, but oh goodness, this is where things get interesting actually. Yeah, in this situation, since p is starting at 0, you have to be careful. Let's actually take a detour and get a first, because getting a is actually more important than getting d at the moment. Your a value is what you get when you put this there. You see, you always have to look at it that way. When you put this over there, that's how you get a. You see, so getting a, it is equal to 1/3 with a 0 here, and then here you have 1 plus a sixth. This is going to give you 1/6. That's your a value. Your d value, you can still do this same formula. It doesn't matter. This one has nothing to do with a. You can still just do t2 minus t1, meaning you can actually put a literal 1 and a literal 2, an actual value 1 and an actual value 2 where p is, you see. So this formula here, t2, is just going to be 1/3 with a 2 there. And then we said this whole thing here, you have to subtract what you call with a 1 here. Whoa, bro, ran out of space, like fast. So here we're just going to put all this in the calculator, right? Let's see. So it's like 1 there plus 1/6. So you see, this is what t2 minus t1 is looking like, you see. So all things considered, let's see what we can do here. 2/3 plus 1/6. Then we have 1/3 plus 1/6. You see. Let's just put this in the calculator. Let's see. 2/3 plus 1/6. And then we have minus 1/6 plus 1/6 also. So all things considered, the answer here is 1/3. You see, it's just 1/3. So let's put our value of d as 1/3 because that's what we're getting. So we have a value for everything now. You see, it's gonna make our life easier to get k. So let's just see. It's a 5-mark question, so we can see it's quite a lot of things. So let's just start. Where Sn is, let's see if there's space down here. Oh, I'm running out of space, bro. So where Sn is, let's put 121/6. Yeah, let us do that. 121 over, we're putting what? 121/6. Yeah, we're putting 121 over the 6 there. So let us do that. You see, 121/6 is equal to our n. We said it's k plus 1. Our a value, we got it to be 1/6. And then n is what we're looking, n is k plus 1. Our value of d is 1/3. Don't forget the brackets. So all this being done, you can see that we're just taking it easy, nice and calm. We're not even doing any heavy lifting. So for you to be able to know all this, like I promise you, all this is showcased on the courses platform. You see, that link to that is in the description. But anyways, let's get on. Here we want to solve for k. So let's deal with what's inside the brackets first. K plus 1/2 here. This is like 2/6, which is like 1/3. And then we have here 1/3 with a k, and then plus 1/3. And then here we still just have 1/6. So a third plus a third is going to give you 2/3. Let's see here. K plus 1/2 is out there. This plus the third is going to give you 2/3. This is just the third k, so it's like you can put k over 3. That's going to make life a bit easier. In this situation, I mean, you could just multiply this fraction inside. You see, a fraction times a fraction, you work with the top. Let's see here. This is going to be times 2 here over 6. And then this times that is going to give you k with k plus 1/6 also. This is also over 6 here. So fortunately, everything is over 6 at the moment, you see. So you can just multiply by 6 everywhere so that the 6 just falls out. See, times 6, the whole thing here times 6. So that you have 1, 2, 1, 2 with k plus 1, k with, let's just do things simple. Let's just multiply inside the brackets. You see, 2 times the k here is going to be 2k plus 2. And this is going to give you k squared plus k, right? Then this is going to give you k squared. 2 plus 1 is going to give you a 3. 2 minus 1 to 1. It's going to give you negative 2 minus 1 to 1. That's going to give you negative 119. This, I mean, like we might as well just work it out using the quadratic formula. K is equal to minus b plus minus b squared minus 4 ac, the whole thing over 2a. So k here, let's see our values of k. Hopefully we get something that looks normal, because if it looks crazy and strange, it should actually be a whole number. Otherwise we did something wrong. So a positive whole number. Negative 3 plus 3 squared minus 4 times 1. Negative 119. 2 times 1. It's wrong. We did something wrong. Okay, I did something wrong. How about bring it together? So we both did. Okay, whichever way, if maybe you spotted the error. I need to just, yeah, the way I was writing all this, it's just, ooh, come on, bro, come on, man. It looked like it's all working out so nicely, you know? But let me try and see if I can trace the error. So this is just a third, yes, yes, yes. And then if you multiply inside here, it's like 2k, blah, blah, blah. k times that, let's see here, k squared. Then you have like 2k here plus 1k, that's a 3k, this squared minus 1, that's fine. And then you have what do you have here? Let me see. Come on, man, come on. Let's see what can we do here. Minus b plus minus b squared minus 4ac, k is equal to this. Sure. We have to trace these values, these individual values that we use. So n, Sn, there's nothing wrong. N, there's also nothing wrong. N minus 30 plus 1. N is fine. Our a value, we put a 0 there. A is 1/6. That's okay. And then our value of d, we said what you call t2 minus t1. So our value of d, we put 2 where p is, we added yes, and then we got put 1 where p is, yes. In the calculator we got 1/3. Let's try that in the calculator again. I think you probably spotted the error somewhere, but in my mind I'm still just like, bro, where is the error? Where is the error? So in terms of you checking for errors and all that, I mean, yeah, it does get a bit frustrating, but if you're gonna get the marks that you want, you obviously want to get into the habit of knowing that errors are inevitable, so you just have to hunt them down as best as you can. So, oh, there's the error there. Inside the formula, it's supposed to be n minus 1. You see? So this is n, right? Minus 1. So if it's n minus 1 here, it means that k is going to be left on its own, meaning it's going to be a third times the k only, meaning this won't be there. So meaning that here, you'll be multiplying by 1/3. See, so you have here, this 2 won't be there. This is still just fine the way it is. And then here now, you would have just k plus 1. And then here now, we can adjust all this. You see, there we go. So spotted our error nicely. Then this one, what is this one going to be now? Let's just see, k squared times the k there is fine. This, yeah. So from here, it's going to be k squared. Put it in red. Just like k squared. K plus k is like 2k. 1 minus this is like negative 120. So yeah, this we can obviously just use the quadratic formula again. You see, minus b so this is like minus b plus minus b squared. So it's like b squared minus 4 ac, the whole thing over 2a. There we go. So k here, let's try again. Let's try again, k. Here we go again. Minus b plus minus, well, we're using plus first, b squared minus 4. A value is a 1, c value is a negative 120, a value is a 1. So 10, finally. It's supposed to be a whole number. You see, the other option, I don't think it's going to be valid because it's probably going to be a minus or something. Yeah, it is. So we just keep 10 only. So k is a 10. I mean, we did the filtering nicely. We checked for our answer nicely. Again, you see, this is the beauty of going through full papers, because you get to see that if you make a mistake, don't just scrape everything. Trace it nicely, bit by bit. Try and find out where you might have made a mistake. So let us move on to the next question. Question number 3, it says here, it is given that the general term of a quadratic number pattern is this, and the first term is 7. Find the value of b, or show that b is a 4. Well, if this is the general term, and the first term of the first differences is 7. Oh, I read that incorrectly. What that means is you have a sequence, right? T1, T2, T3, going on and on and on. Now, T1 minus T2 gives a 7. And then T3 minus T2 gives a certain value. And then T4 minus T3 also gives a certain value. We don't know what these particular values are. We also don't know what this is also. All we know is a quadratic number pattern has a second common difference. So whatever the second common difference is, we don't know what it is. But what we know is it is equal to 2a. We also know that this is equal to 3a plus b. We also know that the first term is equal to a plus b plus c. Now, what we know is, according to this structure, remember this is Tn is equal to a n squared plus bn squared. No, plus bn only, plus c. In this situation, we already know that a is a 1 because the number in front there is a 1. This allows us to just use this equation to get b, you see, because we can just say here 3 times the 1 plus b is equal to 7. 3 plus b is equal to 7. So it means the 3 has to go to the other side. B here is a 4. Now, the way you will be able to think about what we have just done here is just know the basics of a quadratic number pattern. Just use that. Anytime you're given a quadratic number pattern, it's easier to just lay out the structure and then take it from there. 3.2 for 2 marks says determine the value of the 60th term of this number pattern. So we already have the Tn, right? Tn is equal to, what is this? It is equal to n squared plus 4n. N squared plus 4n plus 9. That's the general term. T60, we have to put a 60 where n is. 60 squared, 60 here, and then 9. Now, in this situation, you have to put the 60 squared plus 4 times 60 plus 9. This is 3,849. There we go. There we go. So all this being said, right? Let us see what we can do. So let's see. With the next thing here, let's see what we can do. Wait, no, we got the answer, bro. We're done. Let's move on to the next question. What am I even saying? 3.3 says the following. Determine the general term for the sequence of first differences of the quadratic number pattern. Write your answer in this format. That's not so bad because from this structure, right, we can just wait, let's see what we can do. So here we have we have the general term, right? So we might as well start the general term of the original number pattern. So that's good enough for us to put in values here, you see, so that we can just get these here. We don't even need the rest. All this is useless. Let's just remove it actually. All we need is term number 1, 2, 3, and 4. Or rather term number 2, 3, and 4. Let's get those. So term number 2, right, is going to be what we get if you put a 2 over there. So 2 squared, let's just put it in the calculator, you know. 2 squared plus 4 times 2 plus 9. Term number 2 is 21. Term number 3, let's put 3 in our space for n there. And then we have 30. You see, 30. There we go. And then afterwards, let's put 4 where n is. This is, let's see there, 41. There we go, 41. 41. All things considered, we can now get the sequence of first differences. So the sequence of first differences, we can see here 30 minus 21 is like what? 9. 41 minus 30, that's like 11. So our sequence of first differences, if you're going to get the general term here, you can see that the sequence of first differences has a common difference of 2. So you already know that Tn is equal to A plus n minus 1b. Remember, your sequence of first differences is automatically always an arithmetic sequence because it has a common difference. So us knowing all this, let's see. Where n is, we know it's just going to be a 7. We're working out the general term, so n stays the same as n. D is the common difference. This we just have to simplify until it's like that. So we have here 2 times n, right, which is like 2n. 2 times a negative, which is like a negative. And then we have 7 minus 2, which is like a positive 5. There you go. There's your answer. So, but then they said we should put p and p. Wow. So in this case, we can just say TP is equal to 2p plus 5 because it looks like the variable they want us to be using there is a p. So that's okay. It's not a big deal. If you wanted to just have p's all the way from the beginning here, I'm like, we might as well do that just to satisfy what they want, you know. TP, 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 P, 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 and 2p. Moving on. Which two consecutive terms in the quadratic number pattern have a first difference of 157? So all we know is these terms, right? These are their first differences. So somewhere along the lines, we have 157. 157, you get it as a result of a certain value and a certain value, you see. They want us to get those certain values, you see. That will give us 157 if you perform your calculation. So the way you're going to do this is, you can always think to yourself, well, one way or the other, right? You already know that in your sequence of first differences, right? You can just find this position. You can just find out what term or what position is this term. Because if you find out it's in like, let me give an example. What we already know is something that's in position number 2, right? You get it as a result of T3 minus T2. Something that's in position number 3, you get it as a result of T4 minus T3. So we just need to find this position in this sequence, and then we'll automatically be able to say that it is between whatever term this is and this term. That's going to be easy to get if we find the position of this term in the sequence of first differences. So let's do that. In our sequence of first differences, let's put 157 over there. Let's find out what position that is in. So here minus 5, that's 152. Divide both sides by 2. Let's see here, 152 divided by 2. That's going to give us 76. So what you now know is this is in position 76 in the sequence of first differences. So automatically you know that this is term number 76 and term number 77, you see. So here you can just say, therefore, term 76 and 77. Let us keep it moving to question number 4. Remember, everything we've showcased on the sequences and series questions, you can get that from the sequences and series online course. The link is on our description. In this question, right, we have question 4 over here. It's a functions question, and it looks as though we're dealing with a hyperbola. Let's see what this question is asking us. It says here, sketched below is the graph of h, right? The asymptotes of h intersect at this point. X value is a 1, y value is a 2. So The first question here is asking us to get a value of P and Q, which is very obvious that they would ask a question like that. It says here, well, the idea is if on the graph you see a +1 here, it means that for P, it has to be a -1. But then for Q, if you see a +2 on the image, it means that for Q, you take it as it is, because P and Q, these give you the asymptotes. You see? Asymptotes. Asymptotes. That's how it is. That's what your standard form gives you. So with all this being said, right? 4.1.2 says calculate the coordinates of x. No, calculate the coordinates of the x-intercept of h. Calculate the coordinates of the x-intercept of h. So getting the coordinates of the x-intercept of h, you can just make y as 0 in the equation of h. Because the equation of h looks like this, right? 1 over x. Is it a 1 at the top? It's a 2, bro. No, it's a 1. Oops. This is like -1 plus the 2, right? And then you want to make y as 0. So you're going to solve for x here, right? Solving for x, we have the 2 going to the other side. And then this is over 1. Now you can just cross multiply. 1 times 1 is a 1. -2 times this is like -2x plus 2. And then the -2x can go to the other side. 2 minus 1 is a 1. Divide both sides by 2. X is just a half, you see. So what you know is that x here is a positive a half, which kind of makes sense because it looks like it's in the middle of 0 and 1 anyways, you see. So this is like a positive a half. And then with all things considered, right, we can keep moving forward. Everything looks okay here. It doesn't look like we're dealing with anything difficult. It says the next question, write down the x-intercept of g if g of x is this equation. So we have to find the equation of g of x first, because the equation of g of x is what you get if you put x plus 3 in the equation of h, wherever x is, you see. So let's do that. Let's see, in the equation of h here, let's put x plus 3, right? Let's see here. Let's take the green. So here, hx plus 3. You're gonna have here x plus 3, right? Then -1. So what is this gonna be? 1 over 3 minus 2. 3 minus 1, that's a 2. Right? And then what else do we have here? What else do we have? We also have what is this thing here? We have what do we have though? Let me just try and see. We have what do we have? Come on, bro, come on. Why does it seem so weird now? Let me see. Let me see. Yeah, let's just move on. Let's just see. From here, you're going to get, what are you going to get, bro? Yeah, this is all you end up with, actually. This is actually, you can just label it the equation. You can just label it g of x. This is the equation of g. You see, so they say you should get its x-intercept. So getting the x-intercept of this graph, you're going to make this a 0. 1 over x plus 2. So the 2 can go over to the left, becomes a -2. Okay, so from here, we can just put this over 1. And then we can cross multiply. 1 times 1 is a 1. X plus 2 times this is like -2x minus 4. There we go. So 2x goes to the other side. Negative what? -4 minus a 1 is going to give you -5. Divide both sides by 2. -5 over 2 is your x-intercept. Visually, if you're going to have h plus 3, it means your graph is moved 3 units to the left. Funny enough, you didn't actually have to do all this, because you can see why it's just a 2-mark question. It's a 2-mark question because you can just use it. You can just work it out using your head. If the whole thing is moved 3 to the left, it's like, you can think of it like, this is like gonna end up at like -1/2, -1.5, negative 2.5 and then negative 3.5, which is where we are now. Wait, where are we? This is ending up, no, this is negative 2.5, but whichever way, you get the idea, man. You get the idea. Because if it's moved 3 to the left, it's like what? 1, 2, 3, right? But then because of this half over here, you would end up at like 2.5, negative 2.5 rather, you see. But then anyways, let's not overthink it. The graph was just moved 3 units to the left. So the original x-intercept also moves 3 to the left. For 2 marks, they say it here. The equation, we should get the equation of an axis of symmetry of H. Wait, they said the equation of the axis of symmetry is this equation. Determine the value of t. So this is clearly the equation of the positive axis of symmetry, because your hyperbola always by default has 2 axes of symmetry. There's one that's a negative, and then there's another one that's always a positive. You see? So this being said, the one with the positive gradient always has an x-intercept of, we don't know, but the one that's a positive, right? Okay, this is not to scale, so that's not good. It's definitely not to scale. Yeah, let's just draw a dotted line. This dotted line, the equation is going to be y is equal to x plus the t that they're talking about, the y-intercept. So to get the y-intercept, fortunately, we can just throw in a coordinate that the graph passes through. And our axis of symmetry always passes through where the asymptotes meet, you see. So this is like positive 1 and a 2. So y value is a 2, x value is a 1. This is like 2 minus 1 is a 1. X-intercept is a 1. So the equation here, why did I do it up there? Let me just do it here. Take what we have here, copy, or rather cut it, and then we can put it down over here where our answer is supposed to go. Paste, 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 paste. So this being done, that's why it's just a 2-mark question, because it's quite straightforward. Let us keep moving forward. 4.1.5 says determine the values of x for which this equation is bigger than negative 2. Wow, determine the values of x for which the right-hand side is bigger than negative 2. So this is quite, it doesn't look like it's going to be a difficult question, because this we can just work it out algebraically. We can cross multiply. You're going to have negative 2 x minus 1. 1 times 1 is a 1. And then you can put everything on one side, negative 2x plus 2 minus 1. And then you're going to have here negative 2x plus 1. And then here you're going to take the 1 back. Weird, but it is what it is. Then you're going to solve for x here. The only thing is, if you divide by a negative, your sign has to change sides. You see, that's just the law. So x is bigger than a half. Not a difficult question, nothing crazy. So x has to be bigger or equal to a half. For example, if x is a half here, you're going to have 1 divided by a half, which is going to be like a 2. 2 is bigger than negative 2. But whichever way, all things considered, as long as you're considering x values that are bigger than a half, you'll be good, as we have just seen. Next question, 4.2 says, you have an equation of a parabola here. This parabola, y-intercept is negative 5, so that's very important. We've already gotten this value here. So don't take this kind of information for granted, you see, because it's going to help us, you see. It's really going to help us. So don't take it for granted. Let's move on. All things considered, let's read some more, right? It says here, g of x is this equation. It is also an exponential graph sketched down here. And then they said here, E and H are the x-intercepts of f. So there's E and H, right? So there's E over here, H over here. Okay, those are the x-intercepts, fine. And then they said, before we move on, you can already almost see that the asymptote here is going to be at -5 because the graph is like avoiding -5. Visually, that's what we're seeing. So we can go with that. C is the y-intercept of f, and it lies on the asymptote of g. Thank you. The two graphs intersect at D, so they share a coordinate here. D also looks like the turning point of the parabola, but oh, they actually confirmed it. Very nice. So that's very, very useful. So much information. Getting the coordinate of C, x value is automatically at 0. The y value is going to be a -5, you see. And then D is the turning point. So we can get the turning point by using the turning point formula. Like the x, like since you're in grade 12, right? You want to remember that getting the equation of getting the turning point of anything, you can always differentiate and make your equation equal to 0. It works all the time, you know. For a parabola, you will normally want to use x is equal to minus b over 2a to get the x value of the turning point. But then that formula comes from differentiation, you see. Because if an equation of a parabola looks like this, ax squared plus bx plus c, if you're going to get the x value of the turning point, you want to differentiate your equation, right? 2 times a, which is 2a, then you have b here, because 2 times b, 1 times b is b, 1 minus 1 is a 0. Derivative of a constant, it falls away. So this is your first derivative. If you make it equal to a 0 and you solve for x, the b goes over to the left. You have 2ax, divide both sides by 2a. You're going to have here x is equal to -b over 2a. You see, that's so whether you use this formula or not, you're still just using differentiation, you see. So let's differentiate it. Since we've already just done this, we might as well even just say x here, the x value of the turning point is going to be -b over 2a. A is a 1. We have here -4 over 2, which is like -2, which does not make any sense because this is supposed to be a positive number. So we made a mistake somewhere. A negative and a negative gives a plus. There we go. Moving on, x value is a 2. And then, since our x value is a 2, right, what can we do? We can do what? We can get the y value by putting the x value into the equation, you see. So the original equation, let's put an x value of 2. It's going to be 2 squared minus 4 times 2 minus 5. This is like 4 minus 8 minus 5. It's like what? 4 minus 8 is like -4. Minus 5 is a -9. So, yep, there's our coordinate of our g. X value is a 2. Y. They want us to get a and q. So they're practically asking us to get the equation of the exponential graph. So getting the equation of the exponential graph, what do we have? What do we have now? Equation of the exponential graph. Let's see what we're gonna get there. Equation of the exponential graph. It is going to give us the following. Well, firstly, q we have, fortunately. So let's see here, a to the power of x with a q. And then you have g of x. And then let's see. Cut this thing here. And then we're gonna have this pasted. Then we're gonna have let's see, q we already said it's a -5. We can see it. And then fortunately we can just put in a value that the graph passes through, a coordinate that the graph passes through to get a value of a. You see, so q, we know it's a -5. And then x, we can put in this x value here. Y, we can put in that y value because they both pass through D. You see. And then 2 squared here is a 4. And then here -9. Solving for a, -9 plus 5 is like -4. Divide both sides by 4 here. You're going to get -1. So here, therefore, you have A is -1, Q is a -5. So, I mean, why am I even putting therefore? It's kind of weird. Anyways, that's how you're going to get these two things, you see. Nice, simple marks. 4.2.4, right on the range of G. The range of G, I mean, it's Y values below -5, you see. Y has to be smaller than -5. Nothing crazy there. Determine the value of K for which this equation will always be positive. 4.2.5 here says, determine the values of K for which the equation of, or rather, for which the value of f of x minus k will always be positive. So remember, f of x is a parabola. So you have to remember that the value of k here, right? The value of k here is moving the graph vertical up or down, you see? Moving graph up or down, you see? So the idea is, if you think of it nicely, right? Your solutions to this equation, right? So here the roots of this determine the values of k for which this equation will always be positive. So this is a scenario where these are y values. These are y values. So you're adding to it or you're subtracting from this y value. So they're asking us, where will this graph have y values that are positive? You see, that are positive. So all that being said, right? All that being said, the one thing we do definitely want to consider is looking at the way it is right now. We have the y value of d. See, like the y value of d here, we worked it out nicely. The y value of d is equal to -9. So what we already know is this here, right? The y value here is equal to -9. You see, -9 minus 9. Now, since this value is equal to -9, what you already know is that one way or the other, right? If you move this graph 9 units upwards, it's going to have its x-intercept over here, starting from where the y-intercept is at 0. And then if you move it anything above 9, it's going to have y values that are all positive, you see. So for us to have that, our value of k needs to be smaller than -9. You see, k needs to be smaller than -9. The reason why k needs to be smaller than -9 is because here we have a negative, right? So a negative multiplied by a negative will be giving us a plus, meaning the graph will be moving upwards. So for it to move upwards, the k value has to be a negative value, you see, because a negative value minus multiplied by the negative here will give us a positive number, which is how this graph is going to be moving upwards. So moving on from here, you can also see why this was just a 2-mark question. It was mainly because of all this here, you see. So all things considered, let's move on. Question number 5 says the following. The graphs of G and the inverse of G are shown in the diagram below. And then it says your D, which is clearly the x-intercept of the graph of G, and B, which is the y-intercept of the graph of G. Then it says your C is the x-intercept of the inverse. C is the x-intercept of the inverse. Then they say that the graphs of G and the inverse intersect at A. Okay, so the one thing is, since they meet at A, right, it means that A has the same x value and the same y value, because this is the line of inverse. Remember, the line of inverse, its equation will always be y is equal to x. So all things considered, right, if the equation is equal to y is equal to x, well, the other thing is they gave us the equation of graph of G. This is the y-intercept, right? So this is like the coordinate here is 0 and 6. Automatically, since this is the inverse, this coordinate flipped around, you see, 6 and 0. But yeah, let's just carry on. Let's not do too much unnecessarily. The first question here, they say write on the coordinates of B. Okay, that's straightforward as we saw. 0 and 6 over there. 0 coordinate 6. And then from there, they say determine the equation of the inverse of G in this format, right? So getting the equation of the inverse in this particular format, what is it going to be? The inverse, right? You're going to take the original equation, 2x plus 6, and then you swap x and y, you see. 2x plus 6. Inverse means x becomes y becomes x, you see. Well, you see why you're going to put an x over there, and then here you're going to put everything on one side except for the y, and then here you're going to divide by 2, you see. Divide by 2, divide by 2. This is like a half x minus 3. This is like a y, so you just the symbol that I wanted, you see. Half x minus 3. This is actually a very, very simple question. So let's just take advantage, you see. Determine the coordinates of A. A is the point where the two graphs meet. So that one is not a problem. You can just say the equation of the one graph. You're going to say g of x is equal to the equation of the inverse. So it's going to be 2x plus 6 is equal to half x minus 3. You see. And then you're going to put here 2x over 2x, and then negative 3 minus 6, that's like negative 9. If you divide both sides by 2, your calculator is going to give you, what is this now? Is it like a negative 3? No, it's like a negative 6. So since the x value is the same as the y value, the coordinate of A is just negative 6 and negative 6. See? So don't have to worry about anything over there. Nothing crazy, nothing major. So moving on from here, we have 5.4, right? 5.4 says the following. It's a 2-mark question. This 2-mark question says calculate the coordinates of A, calculate the length of AB. A we have, B we have, so let's just work it out using the distance formula, you see. So using the distance formula, AB is going to be equal to, let's see, A here is like negative 6 and negative 6. B is x values are 0, y values are 6. So this is like 0 minus that, so it becomes a plus. And then you have 6 minus that, it becomes like that. So that's like 36. 6 plus 6, that's like 12. Squared is 144. This is going to give you 36 plus 144, that's like 180. So this is all in all 100 and square root of 180. I mean, if you want to put this in the calculator, I mean, it's just going to give you what you may call 6 square root of 5 if you want. You can put it like that. 6 square root of 5, nothing crazy. So with that being said, let's see what the next question is saying. 5.5 says get the length, get the area of ABC. So all things considered, the length of ABC is, I mean, the area of ABC. Let's see what we're going to get here. There's BC over here. There's C here, B here, A there. So if you're going to get the area of this shape, right, it's really not a difficult task. The reason being, let's see. So we have this here. The idea is you have to remember that this shape is symmetrical. So automatically this is a 90-degree angle. The reason for that is you have to keep in mind that all logic is going to tell you that if this line here is the line y is equal to x, you have to remember that this line here, right, it's symmetrical. The distance over here is the same as the distance over there. And this line passes through the origin. All logic will tell you that this is cutting that because of the nature of how inverse works. So since this is a 90-degree angle, all we need is the distance of BC and the distance of A, and let's maybe label this M, see, which we can say the midpoint of BC, like that. So the midpoint of BC, right, we can say this here and this here get its midpoint. So let's do that first. Let's get the coordinates of M, you see. Coordinates of M, I'm gonna say 0 plus 6 Wait, is it 0 plus 6? Yeah, because it's going to be 2x values added together, 0 and the 6, 6 and the 0. See, each of them over 2, you see 6 plus 0 over 2 also. M here, this is like 3 and 3. So we have the coordinates of M, meaning we can now get the perpendicular height, you see, because the height is going to be equal to AM, you see. Now AM is just going to be, let's see, where is A? Remember, the coordinate of A is -6 and -6, you see. So this is going to be -6 minus 3 squared, and then you have like -6 minus 3 again, squared, and then you have like -9 squared, which is like 81, and then 81 again, and then you have like 162, and the square root symbol. Your calculator, if you put square root of 162 in there, it's going to give you 9 square root of 2, which is okay, all things considered. So you have the perpendicular height now. The base, clearly it's just going to be the length of BC. Let's get the length of BC. You see, the base is going to be equal to BC, which is going to be equal to square root symbol. You can just say here 0 minus 6 squared. Let's see, 0 minus 6 squared plus 6 minus 0 squared. -6 squared is like 36, and then another 36, square root of 72. There we go. So 6 square root of 2. So this is like 6 square root of 2 BC. There we go. So with all this being done, let's move on to actually getting the area now. So the area, what are we going to get as the area here? The area is going to be equal to half base times the perpendicular height. So this is just going to be a half. The base is 6 square root of 2. Perpendicular height is just 9 square root of 2. So all this in the calculator, let's see. This times 9 square root of 2 times a half is going to give us 54. So this is 54 units squared. 54 units squared. There we go. Nothing crazy. Let's move on to the next question. So you see, these questions are quite simple. If you want to be able to simply answer questions the way we're answering them now, you want to sign up for the online course. See, the link to that is in the description. Question number 6, we have financial mathematics, you see. So financial mathematics, it says 12,000 was invested in a fund that paid interest at M% per annum compounded quarterly after 24 months. So the idea is, if that's the case, right, we automatically know that, okay, this was invested into a fund. They're not talking about any monthly installments here. So we need to keep that into consideration. Compounded quarterly after 24 months. That's 2 years. And says the value of the investment was this much. Determine the value of M or the interest rate. So it's a compound interest formula question. 1 plus I to the power of N, right? The thing is, if it says compounded quarterly, then it says after 24 months, the value of this investment is this much. So automatically, if it's quarterly, well, firstly, years is equal to 2. So our value of N has to be 2 times 4, which is 8, since it's compounded quarterly. And then our interest, which is M, right? The M% means M over 100. So since this is over 100, right? If it's compounded quarterly, we also have to then divide this by 100 times 4 because it's compounded quarterly. So this is the value we put where I is. This is the value we put where N is. Our initial value was 12,000. Our value after the time period passed is 13,459, you see. So all this we're gonna put over there. All things considered, let's see what we're gonna end up with here. This is 12,000 is equal to 13,459. Interest rate is M 400. N is like to the power of 8. All this here we can say divided by the 12,000. No, divided by the 13,000, bro. 13,459. There you go. So this is also 13,459. And then we have here, this goes away. It's like 1 plus 400, the whole thing to the power of 8. So this figure here, right, in the calculator, I don't think it's going to be any simpler. So 1200134559. So you want to say here shift square root. So it's like square root symbol with the 8 here. This cancels that. This also here. And then you have 1 plus m over 400. Then here you can just keep that also. You don't want to simplify because with financial maths, you don't want to simplify unless it's like the final answer. So since we're solving for m, the 1 is going to go over to the other side. Let's see here, 459 minus 1. And then obviously to get rid of the 400, we have to multiply by 400 on both sides, times 400. The whole thing here times 400. So what you're going to get is your value of m. Let's see in the calculator. It's going to be big bracket, shift square root symbol. We have an 8 over there. In our fraction, we have 12,000, 13,459. And then we have minus 1. It's there, minus 1. And the whole thing here times 400. This is going to give us, whoa, it's giving us a negative value, bro. Come on. Man, seriously? Yeah. Oh, no, I mixed them up. Dude, what the hell, bro? Seriously, it's so annoying. Like, this is so dumb. The initial value was 12,000. Dude, come on, man. Hey, I feel like an idiot. Like, seriously, can't even hide it right now. 12,000. So this is 1, 3, 4, 5, 9. That was such a dumb mistake. Yeah, like, seriously. Excusez-moi. 3, 5, 4, 9, 2, 0, 0. I have to change all these here. Let me actually even just do this. See? Add a 0, bro. Let's just do this. Copy. Remove this. Remove this. And then we just replace it. Paste. Paste again. Hey, I was wondering why am I getting a negative value? So I actually just was operating on autopilot, to be honest, until this answer comes out and it's like, whoa, what's happening, bro? Come on, gotta change that. So 1, 2, 3. That's giving you 5.78. 5.78. That's your value of m. So if you test it, you can just put 5.7 there. See if it's giving you 13,459. So let's see, 12,000. Then we have like 1 plus m, which is 5.78. The whole thing over 400. The whole thing to the power of 8. It's giving us 5. Yeah, it's giving us the correct answer. So let's move on. Okay, so 6.2 here says on 31 January 2022, Chino deposited 1,000 rands in an account that paid interest at 7% per annum compounded monthly. He continued depositing 1,000 on the last day of every month. He will make the last deposit on 31 December 2022. So he deposited 1,000 into an account, and then it does that up until the end of that same year. So it's like January all the way to December. That's 12 months. Will Tino have sufficient funds in the account on 1 January 2023 to buy a computer that costs 13,000? Justify your answer with appropriate calculations. This is quite straightforward, nothing crazy. So it looks like they're going to give you marks for choosing the correct formula. So it's going to be the F formula. The reason why we're using the F formula is because this is a compound interest question where there are monthly installments being made. So let's see what we have here. The monthly installments, they're making installments of 1,000 monthly. The interest rate is 7.5% over 7.5% compounded monthly. So it's 7.5% divided by 12. And then what we also know is it's over 12 months, you see. Now, if you're going to work out if he has 13,000, you have to just work out a value of F and see if it's equal to 13,000. So doing that, we're going to have here F is equal to 1,000. I reckon he probably is going to have 13,000. If not, then yeah, Carl. 7.5% over 12. Remember this percentage symbol, you have to put it in your calculator. And then this whole thing here is over 7.5% over 12. So let's put all this in the calculator and see what we end up with. 1,000. And then we have in here 1 plus the 7.5%. And then we have here 12. We have here to the power of 12 minus 1. This is 7.5 shift percent over 12, right? And then what do you have here? Sure? Dang it. Yo, that's rough. What a wow, bro. Yo, sure. Terrible investment. So it's like 12,421.22 if you round off to 2 decimal places. So here you can say therefore, no. As simple as that. 6.3 said on, wait, it's the same question twice, bro. Come on. 6.3 said Tabo plans to buy a car that costs 250,000. He will pay a deposit of 15% and take out a loan for the balance. The interest on the loan is 13% per annum compounded monthly. What is the value of the loan? So obviously the value of the loan is whatever is left after you move 15%. So we have to work out 15% of 250,000. 15% of 250,000. Let's see what that gives us. 15 shift percent of 250,000. That's like 37,500, right? So we have here 37,500. So if you remove that, you're gonna have 250,000 minus 37,500. What do you have there? 250k minus the answer. You have like 112,500. I mean, no, 212,500. And then it says here the first payment, no, the first repayment will be made 6 months after the loan has been granted. So yeah, the first payment will be made 6 months after the loan is granted. The loan will be repaid over a period of 6 years after it has been granted. So what is the monthly installment? So the thing is, you have to take note of the fact that 6 months the money was gaining interest without being paid. After those 6 months, that's the amount you need to work out the monthly installments for. So you're going to start off with the compound interest formula, right? This compound interest formula, you're going to make your value of P equal to the 212,500. That 212,500, you remember, it is going to gain interest for 6 months, you see. N is equal to 6. It says It will be made 6 months after the loan is. So here you may be thinking, if it's made 6 months after the loan is granted, it means that the money gains interest for 5 months, and then the 6th month you start paying. So it says here what was the interest rate? They said it was 13% per annum compounded monthly. So it's going to be 13% over 12. So here your value of A is going to be 212. This value here multiplied by the bracket. And we have 1 plus the interest, which is 13% over 12. The whole thing to the power 5. And then we have here 212,500, 212,500. And then this here 1 plus the 13%, 12, the whole thing to the power 5. And then here this is like 224,000, 262.5254. That's the value of A, right? Yeah, that's how much you're going to be owing. So if you're going to work out the monthly installment, you have to use the P formula now. X 1 minus 1 plus I to the power of negative n. Oh, it's supposed to be a negative, bro. Come on. Negative n, the whole thing over I. And then since you want to work out x, you can just isolate x. So here you can multiply by I, multiply by I. It's going to be pi is equal to x in this big bracket here. So you're going to divide everything by the big bracket, right? If you divide by the big bracket on both sides, you're going to have pi over here, right? The big bracket at the bottom. And then here you can have x on its own. So therefore your value of x is going to be 2, 4, what? 224, 262, 5254. And what else? Let's see here, 5254. And then you have the interest rate is like 13% over 12. And the whole thing here is like, what is I? I is like, oh, no, 1 plus. No, it's 1 minus, bro. 1 minus the bracket, 13% over 12. And this is like, what is n? N is, whoa. Oh, ha. 6 years times 12 minus the 5 that has passed. What are you going to get? 60 minus 5, that's like 55. Wait, 12 times. Wait, what is 12 times 6? Is it 60? No, 72, bro. Bro, your maths need help. Your mental maths needs the help. This is 67. We love to see it. We love to see it. So x is equal to this whole thing here. What do we need here? Power of negative 67. So everything looks all good. Let's just throw it into the calculator and see what it comes out as. 224,262 point this big bracket. No, inside the bracket we have 13 shift percent over 12. And then you have the 1 minus open bracket and close bracket. 1 plus 13 shift percent over 12, the whole thing here to the power negative 67. 4,724.96. There we go. Let's keep on moving. So the idea is the format that we're using and the logic and all that. That's how you're gonna work out questions like this. No doubt. Let's move on to question 7. Question 7 says determine the first derivative from first principles. This is the equation. So if you're going to determine the first derivative from first principles, you just have to remember the formula. This is what the formula looks like. Lim h goes to 0, x plus h, f of x, and then h. And then it says here, so what you want to do is get this value first, you see. This value, it's a matter of you putting x over there and x over there. So you're going to have here x plus h, right? So you're going to put here x plus h squared, and then x plus h. Let's simplify this. X squared plus 2xh plus h squared plus x plus h. That's as far as we can go with that one. So in our main equation now, f prime, we know it's equal to lim h goes to 0. So this whole thing here, right? Let's copy it. I'm gonna paste it over there. Let's see here. And then from here, you see we have to subtract f of x. So it means you have to subtract, you're gonna say negative x squared and then negative x. And then the whole thing over h. Now the good news is, if what you're doing is correct, if you've done it properly, you'll always see that your terms where f of x is, they'll always be cancelled out. What you're gonna have here left is just lim h goes to 0. And then you're gonna have here 2xh plus h squared, and then plus h over here, right? So the good news here is, obviously you can now take out h as a common factor everywhere. You can take out h at the top, and you can take out h at the bottom, you see. So let's see what that looks like. So you're gonna take out h at the top over here. It's gonna give you 2x plus h here plus 1. The whole thing here over h. The top one and the bottom one, they cancel out. You have lim h goes to 0, and then you have like 2x plus h over here plus 1. Now you put a 0 where h is, and you're gonna have here h goes to 0. This is like 2x plus 1. And then this is your no. When the h has been put in there, this is your final answer. You don't have to put the lim and all that. F prime, there we go, which is definitely correct, because 2 times the one in front there, and then here 1 times the one in front there. And obviously if you remove 1 from each of the exponents, you will have 1 left for here, and then x to the power of 0 here. Moving on to the next question, 7.2, it says determine the first derivative if f of x is equal to this equation. So it doesn't matter the exponent that you have. Your laws don't change. 5 times 2 is a 10. 5 minus 1 is a 4. 3 minus negative 3 is a negative 12. 4 minus 1 is a 3. 1 times 8 is 8. There you go. So all things considered, this is your first derivative. Oh, we were done. 7.3 says a tangent to this equation has a minimum gradient at the point -1 and -7. So this is very important. For which values of x will the graph of g be concave up? So remember, the graph of g is either a cubic function that looks like this, right? Or it's a cubic function that looks like that. Now remember, the center of your graph is what splits up concavity. So here, this side here is concave up, this side down, this side here down, this side here up, you see. So with all this being said, you now need to be super duper careful. When I say you now need to be super duper careful, this is what I mean. I mean that if they say here this equation has a minimum gradient at this point, so a minimum gradient, you have to remember that one or the other, this gradient here is a 0, the gradient there is a 0, here also is 0, here also is 0. Now, if you want to keep in mind what we know, right, from this, all these values on the left, they have positive gradients. These have like negative, this also has like negative. Then here you have like positive. And then obviously with what you may call, with this one, negative gradients here, positive up until there, then negative again. So this question, you don't want to take it too lightly, because I mean, when they use words like minimum and all that, yeah, it can get a bit tricky. But if this, let's just read again, it has a minimum gradient at this point. So what you can actually do is you can get the gradient equation of this graph. And then if they say it has a minimum gradient at this point, okay, let's get a gradient equation first, and then you'll see the logic. The gradient equation looks like this: 3ax squared, right? Plus 6x plus b. These are what the gradient equation looks like. So they said it has a minimum gradient at this point. So having a minimum gradient, it's when you differentiate your gradient equation, right? And you make it equal to 0. So they've basically told us if you differentiate your gradient equation, right, and you make it equal to 0, oopsie, excuse me, let's finish this. If you differentiate your gradient equation and you make it equal to 0, this is the point that it says it has a minimum gradient at this point. So if you differentiate it and you make it equal to 0, your x value there is equal to -1. So this is giving us a value of a. The reason why the value of a is useful is because as long as we know the value of a, we're able to determine whether the graph is concave up or down, you see. So the value of a here is a positive, you see. So a being a positive, it means that your value of a here is a 1. So as long as you have a value of a that's a 1, it means that you're dealing with like a positive gradient, you see. So meaning that if you look at it nicely, it has your graph is concaved up on the right side of your point of inflection. So what we know is the point of inflection is at -1, based on what this information is telling us. So we're going to say here x has to be bigger than -1. So these are the kinds of questions where, I mean, you definitely want to watch this again for you to get a better understanding. But obviously, for more tutorials on different ways to answer these kinds of questions, you can always just find the link to the online courses in the description. Question number 8. Question number 8 looks pretty good. But let's find out if it actually is good. It says here, the graph of y, which is the first derivative, is a parabola. So it means the original equation, which is the equation of f, is a cubic function. And then it says here it passes through these points. Then it says determine the value of m, n, and k. So the big idea is, obviously, your first derivative, there's certain pieces of information that you never want to forget. And let's put it this way. Firstly, the y values of this graph, they give you the different gradients of your original function. So what I mean is, your original function is a cubic function, right? F of x is equal to ax cubed plus b of x squared plus cx plus d. Now the big idea is, with all this being done, what we know is your first derivative, they are telling us that it is equal to, well, whatever they've told us, our first derivative, we know that it is technically this equation here, of which this differentiated would have been like 3ax squared plus 2bx plus c. So in my head, I'm thinking to myself, all this explaining and all this talking, it is what it is. But the one thing I'm trying to point out is that you have to keep in mind that this is a frowning parabola. So it means that the initial cubic function would have been a cubic function that goes down, up, and then down again. Our cubic function would have had turning points at 2 places. Now, you have to remember that the y values of this graph, they represent the gradients of the original one. So you see where you have a y value of 0 here and where you have a y value of 0 there. it's telling you that's where your turning points would be. You see, you'd get a turning point over there at negative a third, you'd get a turning point at positive 1. Now, the big idea is between your two turning points, right? You have to remember that that's where you get your point of inflection. So here, right, in between negative a third and 1, that's where you get your point of inflection. So between negative a third, let me just do this. Between negative third, right, and a 1 divided by 2. Let's see what this is. We want to check out which x value is in the middle over there. So here we have negative a third plus 1, right, divided by 2. That's giving us 1/3. You see, 1/3. So what we know is in the middle of our graph, which is the point of inflection, we have positive a third there. These pieces of information, they are useful to us in the following way. Firstly, this is your this is your first derivative, right? So your second derivative is what is going to give you the point of inflection. So the second derivative would look something like this: 2mx plus n. You see, now what we know is if we can throw in a value of x and a value of the what we know is if you make your second derivative a 0, your x value will be the x value of the point of inflection, which is in this case 1/3. So this is giving us an equation that has m and n only, which is somewhat useful to us because we want to get all these variables. So we can label this an equation that has m and n. So the other thing is, fortunately, you have to remember that in all this, you have to remember it's still an equation of a parabola. So this k here is still representing the y-intercept. So k is a 1 by default. You see, k is equal to 1. That's going to give us 1 mark out of the 6. So we want another equation that has m and n. So that's easy because you can throw in any coordinate that the graph passes through. Let's put 1 and 0 into the second derivative. So if you put here as the y value as 0, your x value is a positive 1. So this is like m with 1 squared. And then this is like n with 1. And then k is a 1 also. So many ones. So this is like m plus n plus 1. So we have two equations that have m and n. Here it looks like we can isolate n. Let's isolate n in this equation here. Negative 2 over 3m is equal to n. Here let's isolate n also. Negative m minus 1 is equal to n. And then here let's equate the two n's together. You see, therefore, negative 2 over 3m is equal to negative m minus 1. Everything on one side, we're gonna have the plus m. Then this is negative 1, right? If you add these up together, you're gonna get a positive a third. There we go. So with all this being said, right, let's divide both sides by negative 1. You see, let's divide by let's divide by a third. Divide by a third here, divide by a third here. You see, there we go. There we go, cut. So m here is equal to, so negative 1 divided by a third, you have to be careful here, this is giving us negative 3. So m is a negative 3, as expected. You see, m is supposed to be a negative value. So n, we can then say here, therefore, negative 3. So minus negative 3, right? So let's do this. Wait, hold on. Minus negative 3 minus 1 equal to n. This is like positive 3 minus 1, that's a 2. So n is a 2. So we have m, we have n, and we have k. So, I mean, you could test out your answer one way or the other. You could maybe, let's see, m is like negative 3, right? So let's see, negative 3 x squared, and then n is like positive 2 plus 2x plus 1. So you can maybe put in the x value as negative a third and see if you get a 0. So let's test it out. Negative a third in the place of x. Then you have plus 2, negative a third in the place of x, and then plus 1. That's like 2 over 3. Ah, baga. That's how you know we made a mistake somewhere. Oh, no, I forgot to put a negative in front of the 3. Yep, it gets a 0. So we're all good. Perfect. Now it's like what? 8.2, right? 8.2 for 3 marks says the following. It is further given that this equation is the equation of f of x, determine the coordinates of the turning points. So you see why they're giving it 3 marks, because the coordinates of the turning points, firstly, the x values, you have them already. So you can just get the y values. So you see negative a third here. Let's do this. Negative a third, negative a third squared, negative a third plus 2. Let's see what the corresponding y value is in this equation. You see, negative a third, the whole thing square, cubed, my guy, cubed, plus negative a third, and then the whole thing squared, plus negative a third, plus 2, right? This is like 49 over 27. 49 over 27. So the next one, you have to put positive 1. 1 cubed, 1 squared, plus 2. This is like negative 1, plus 1, plus 1, plus 2. This 2 plus 2, which is 4, minus 1 is 3. So these are the two coordinates of the turning points. If you leave it like this and like this, that's 100% okay, because that format is a coordinate already. But if you wanna just, write it like this, feel free to do that. And this one here is like 1 and positive 3. 8.2.2 says, draw the graph of f, indicate on your graph the coordinates of the turning points and intersects with the axes. Wow, so you have to get the x-intercepts. No, intercepts with the axes. Yeah, so we have to get the x-intercepts and the y-intercept. Wow, okay. So the thing is, since we need to get the x-intercepts, right? I normally always use long division to like factorize. But then in this case, I think our calculator can bail us out so that we don't have to worry about doing any long division. So in your calculator, you can use the table method. You can say table. So to get the x-intercepts, let's try it out. You can say mode. All right. See here, mode and then table. So like mode, table. And then you're gonna put the equation of the graph in your calculator. Alpha cubed plus alpha x plus x again plus 2, right? You're starting here at like let's start at I usually put like negative 8 up until positive 8. So say negative 8 up until positive 8, and then the step I can put 1 there. So yeah, it's giving us, you want to look for one value that you want to look for the x, you want to look for at least one x-intercept so that you can figure out the rest using synthetic division. So the x value is a 2 and y is 0. So that's one of the ones we can use. So if x is let's see here, in our table somewhere we got x here as 2, y is 0. So therefore we know that x minus 2 is a factor. So as long as we know that, you can use synthetic division to factorize your your cubic function. This is how you use synthetic division to factorize your cubic expression. You see, you're going to say x minus 2, and then no, you're going to just put something like yeah, you're just going to put something like this. It looks like it's going to work. It looks like we're going to do long division, but meh, we really are not. So, oh no, just do something like this for now. Let's not do anything complicated. So you're going to put the coefficients of your numbers one by one. Negative 1, 1, 1, and 2. And then you're going to leave a line open, you see. And then what you do is you first drop this first number, negative 1. And then what you do is, well, firstly, since x minus 2 is a factor, you just have to put the number positive 2 over here. Since x minus 2 is a factor, you have to put the number 2 here. And then all you do is you're going to say 2 times negative 1, you put your answer here, and then you add this plus this gives you, is it adding or subtracting? What a wow, bro. Is it adding or subtracting? Wow. In my head, I'm thinking it's subtracting, but for some reason, I'm thinking it's adding. But without, if let's say bump into a situation like this in an exam, what you do is try out what you think is correct, and then you can always test it out at the end. But let's see. Let's add first. 1 plus this value is going to be like negative 1, and then you do it again. 2 times negative 1 is negative 2. Then you add. You see, that's going to give you negative 1. And then this times this is going to give you negative 2. Then you add. So yeah, this seems like adding is the correct one because this should always be a 0 if your answer is, if you've done the correct thing. So here now, what you know is when your equation is factorized, you're going to have x minus 2, but then your other bracket has these coefficients. You see, it's going to have negative x squared, negative x, and then it's going to have negative 1. There we go. This is what the equation of f of x factorized looks like. So here you then have, therefore, x minus 2 is equal to 0, or negative x squared, negative x, negative 1. So this gives you, what does this give you now? Let's see. So from here, the idea would be to see if this can be factorized further, of which, if you want, you could take everything to one side, right? This is what you'd have. And then you could then have here, let's see, factors of 1 that give a 1, none. So this cannot be factorized. But anyways, what this means is, if you're gonna draw your sketch, now you just have to be careful. Let's see here. Let's do this. Let's do this. What is next, so let me just see here. We have, what do we have? Oh yeah. So if you're gonna draw your graph, we first need our turning points. There was an x value at negative a third, and another x. No, the first turning point was at negative a third. The other one was at positive 1. So let's be careful. So let's just try and, in terms of a scale, right? You don't have to like put lines on your graph and everything like that. You don't have to do anything like that. Let's see. This here is going to be negative a third. Then let's see. We can maybe put positive 1 somewhere here. Let's see here. Let's see here. Yeah, so this one, the x value is going to be a positive 1. And what we also know is that the asymptote, no. The x value of the point of inflection is at positive 1/3. So that's going to be like somewhere here. You see. So the other idea is, fortunately, we have the y values of the turning points also. So this one is like 49 over 27. What is 49 over 27? 49, 27, that's like 1.8. Yeah. positive 1.8 for the one with negative a third. Let's see. Let's do it. Let's put it over here. See, this is where the y value of the turning point is going to be. And then let's just label that coordinate. Negative a third, 49/27. Secondly, where the x value is 1, the turning point is at where x is at 3a. Let's adjust this because it won't match up with what we're trying to do. So let's put 1 over here so the 3 can be somewhere there. So this is like 1 coordinate 3. So the turning point, it looks like it's gonna there's a turning point, there's a turning point, there's a point of inflection. The x-intercept is at positive 2. So wow, this is quite interesting. Let's put a positive 2 over there. So if this is going to be a turning point, I mean, if this is going to be an x-intercept, remember the graph starts by going down, it turns, and then turns again, and then goes down. Yeah, this is what the graph is going to look like. It's going to look as follows. The y-intercept is a positive 2, remember. So between 1 and 2, remember this here is negative a third and like 49/27. Positive 2 should be like very close here. See, this is what the graph looks like. It's going to come down, turn here, go up, go down. It's going to pass here at, don't mind how this sketch does not look very nice at all, but it gets the job done, because the idea is to show that the graph comes up, comes from down here, turns here, passes through here, has a point of inflection here, and then this is a positive 2. You see this has to be there, this has to be there, coordinate, this you don't necessarily have to put it, but shows that you know what you're doing. Let's see here. Let me see here. Yeah, so this is how you're going to draw this graph. Nothing crazy, nothing major. Let's move on to the next question. Okay, question 8.3. Let's see what we got here. It says here, points E and W are two variable points on the first derivative of f, right? And then they said here, there are two variable points on the first derivative of f and are on the same horizontal line. Okay, so what we know is we're dealing with the equation of f, right? They gave us the equation of f here. Let me just copy it down here. Plus x squared plus x plus 2. Okay, so obviously, the one thing that I can also recommend is the mark allocation. Let's just see how many marks this question is worth. It's a 1 mark question. Whoa, okay. So since it's a 1 mark question, we really don't need to overthink it. So it's on the first derivative, fine, of which the first derivative is a parabola. Let me just get the equation. I don't think we'll need it because, I mean, for a 2 mark question of this nature, yeah, seems like it's going to be a walk in the park. They said h is a tangent to f at e. Okay. So technically, if our cubic function, right, looks like this, it means that our first derivative is going to look like this. Because remember, if your graph of f is a decreasing cubic function, it means that its first derivative, clearly it has a negative a value here. So this is a frowning graph. So they told us that w and e, they are two variable points, and they're on the same horizontal line. Horizontal means the straight line like that. So technically you have e somewhere here, and then you have w on the other side. And then they say that h is a tangent at e. So h would be a tangent like that. Well, let me draw that better. And then they said g is a tangent at w. So this tangent would look like this. And then they said that they intersect at d, meaning they intersect up here. You see, they intersect somewhere up here. Let me just fix this quickly. Whoa. Just fix this here. And then do this here, do this here. So this is where the two tangents meet. And then it says here, this point is D. And then they said, write down the value of A. So if these two tangents are going to meet somewhere in the middle here, the fortunate thing is, remember, a parabola is symmetrical. You see, so if a parabola is symmetrical, it basically just means that whatever this x value is and whatever this x value is, these two tangents would meet right in the middle. So we would need to get the x value of E and W, of which we can get that by finding out, for example, remember, your two x-intercepts here would be the two x values of your turning points. Remember, these are the points where your first derivative is equal to 0. So your first derivative here, if you make it equal to 0 and you solve for x, you're going to get negative a third and you're going to get positive 1. Oh, so yeah, so here you can have negative a third, here you're going to have positive 1, right? So in the middle of negative a third and 1, that's where you're going to get the x value of d, which is whatever the a value is. So we need to get the middle of negative a third and 1. So to get the middle of any two numbers, you just add them up and then you divide by 2. So let's see here, negative a third plus 1 divided by 2, that's like 1/3. Okay, so let's see here, 1/3. There we go. So now we should move on to the next question. That wasn't so bad. Okay, so for this 2 mark question, it says determine the values of B for which H and G will no longer be tangents to F. So one equation is H, the other, one line is H, one line is G. So if these lines are not going to be tangents to what you may call, to the parabola, yeah, that's going to be quite interesting. That's going to be super interesting. So for these lines to not be tangents, they said determine the value of B where these lines are not tangents anymore. So for these lines to not be tangents, well, one thing to consider is that without overthinking it actually, let's firstly find out the value of B, because remember B is a specific Y value. So since B is a specific Y value, one thing we can already see is that one way or the other, the way these lines are laid out, if the gradient of this line, let's say, the only way these two lines cannot be tangents to these, cannot be a tangent to your parabola, this line, you would probably need to change the gradient so that it becomes a bit, a bit steeper. This one, the gradient would also need to become a bit steeper going downwards, but that sounds a bit too complicated. That sounds like it sounds a bit too far-fetched, and it's just like a 2 mark question. Determine the values of B for which G and H will no longer be tangents to the first derivative. Yeah, that's an interesting question. But I think for the purpose of like me not taking too much time unnecessarily, let me do this. Just hit me up on IG, and then I will send the explanation to this particular question, because obviously I'm doing this all on the fly, so I'd much rather just upload the entire paper and then figure this out properly and then edit in like a separate video. But for now, let me just carry on with the rest of the paper. Question number 9. Question number 9 says here, determine the minimum distance between the point 10 coordinate 2 and a point on F. Okay. So it's an 8 mark question. So fortunately, the fortunate thing is, anytime they're going to speak of anything related to maximum or minimum or anything like that, you may want to think of applications of calculus. You may want to think of applications of calculus, but then you also want to be logical depending on the kinds of questions that you have. So this is a basic parabola. It's a parabola that is literally going to be looking like this. You see, it's literally going to pass through the origin. There we go. Yeah, why am I even doing all this? Yeah, anyways, this is fine. So this parabola, they say determine the minimum distance between this point and a point on F. So one or the other, we don't know where this point is. And it is definitely not a point on the graph. Otherwise, there wouldn't be a minimum distance to talk about. So in a situation like this one, right, you want to keep in mind that one way or the other, this kind of a question, you have to be strategic about it. So this point here, you can see that the x value is around 10 and the y value is around 2. So this point could easily be somewhere here. The minimum distance between this point and the parabola is going to be the distance between this line going towards the parabola, and this line would need to meet the parabola at an angle of 90 degrees, something like this. You need to keep in mind that this is the distance we want, but then to get this distance here, we need to keep in mind that this point, let me actually try and do something like that. Yeah, this is the picture that you want to have in mind, because the minimum distance between our point here and somewhere on the parabola, the minimum distance is going to be based on the fact that from here going to your parabola, this has to be meeting this tangent at an angle of 90 degrees. So I can see why this is like an 8-mark question, because yeah, it seems like we're gonna need to do a bit of, yeah, we have to be very thorough, otherwise our hard work will just go to nothing. But let's see what we can do. So the first thing is, let's see here. It's an 8-mark question. Determine the minimum distance between this point and a point on F. Okay, so we know that we have to keep in mind that any point on our parabola here, it has to be a specific point. But the main issue now is finding out what that specific point could possibly be, because yeah, that's a big one. That's a big one. Let me actually pause and think about this question also. If you look at the diagram that I've just drawn here, right, it's clearly dealing with two lines that meet each other at an angle of 90 degrees. So, or that cut each other perpendicularly. So what you can attempt to do is, you can think to yourself, okay, fine, this tangent here, right, its gradient, the equation of this straight line here, we would have to think to ourselves, y is equal to mx plus c. So the gradient of this line here, we can get it by saying what you call your first derivative. Remember, the first derivative of this equation is what gives us the gradient at any point here. So the first derivative here, let's see, the first derivative is clearly just going to be 2x. So what we know is the gradient at any point here, we can get it by just saying 2x. So this is like the gradient formula. We don't know which specific x value we would be using. So what we can actually just say is the equation of this first green line, we can just label it y is equal to m. Well, we don't know what the gradient is specifically, but we can just throw in the 2x and then plus c here, mx plus c. So where m is, we just dropped in the 2x because that's what represents our gradient. And then c would be our y-intercept. Yeah, that's kind of crazy. Yeah, that's like proper crazy. But we don't need all this actually. Let's remove this. All we know is this is what would give us the gradient, right, of our tangent. Our gradient of our straight line here, let's say what we know is the gradient of this straight line here, we know it is x squared minus 2 over x minus 10, right? There we go. So this is what the gradient would be for this line here. This is the gradient of this yellow line. The gradient of our tangent here would just be 2x. So for these to meet at an angle of 90 degrees, what we know is these two multiplied by each other, they have to equate to -1. So what we know is 2x, right? Let's make it a fraction. if you multiply it by this expression here, the whole thing has to result with -1 as the product. So if you simplify this, you're gonna get here 2x, because here this times this gives you 2x to the power of 3. This times this gives you 4x, and then the bottom part 1 times everything at the bottom here. This is all that you have, and then this is supposed to be equal to -1, right? Let's put it over 1 so that we have a fraction and a fraction everywhere else also. Let's carry on. So this is getting quite interesting. So here we have a fraction and a fraction, so we may want to get rid of fractions. We can cross multiply. This times this part is going to give us -x plus 10. 1 times this bracket is just going to give us 2x power 3 minus 4x. Everything on one side, you're going to have 2x cubed minus 4x plus x minus 10 equals to 0. Okay, so yeah, what are we trying to do here? We're trying to solve for x, because if you can find an x value where these points meet, we'll be good to go. So solving for x here, we can actually just use now trial and error. We can use our calculator to like sub in x values and all that. You can actually try 1. Let's see if 1 is going to work. 1 here would be 1 cubed, which is like 1 times 2, which is a 2. 2 minus 4 would be like -2, and then plus 1. Yeah, it wouldn't give us a 0. Let's try 2 positive 2 here. 2 cubed would be 8. 8 times 2 is 16, right? So 16 minus 8 here would be 8 plus 2, which gives you 10 minus 10, that gives you a 0. Yeah, so 2 works. So if you put a 2 here, right, what you can do is you want to show that 2 is a factor, because what we're trying to do here is we want to factorize using synthetic division. So to do that, we have to find at least one factor. So let's say here, let x equal to 2. If x is a 2, we want to show that 2 is a factor, so that we can then use synthetic division for what we need to do. So this is 2 cubed, which is 8, times 2, which is 16, minus 8, plus 2 minus 10, you see. So 16 minus 8 is 8, plus 2 gives us a 10. So this is like 10 minus 10, which is like 0. Therefore, 2 is a factor. Let's actually just make sure that this is at least, in its simplest form, meaning it's going to be, let me actually write it down here. It's going to be 2x cubed. These are like terms. So this would have been like -3x minus 10 equal to 0. So with synthetic division, you want to make sure that your numbers, they are in descending powers properly. So meaning if something is not there, you have to replace it with a coefficient of 0. Meaning this, you want to write it as 2x cubed. Since there's no x squared, you're going to have to put 0x squared here. And then -3x. It's like 3, 2, 1, and then -10 equal to 0. And then to use synthetic division, here's what you do. Since 2 is a factor, right? You're going to put here a 2 with a symbol like this here. And then these coefficients, you put them here, 2, 0, -3, and -10. And then you draw a line. And then what you do is you drop this first number. So from here, you're literally just going to be adding and multiplying. So to start off, you're going to say 2 times 2 is going to give you a 4. The answer, you put it here. Then you add 0 plus 4 is a 4. 2 times 8 is positive 8. 2 times 4 is positive 8. And then -3 plus 8 is positive 5. 2 times 5 is a positive 10. And then you add, you get a 0. If what you're doing is correct, you should always end up with a 0 here. So what this means is when your expression is factorized, since 2 is a factor, your first bracket is going to have x minus 2. Your second bracket is going to have 2 x squared plus positive 4x plus 5. You see, this is what your expression will be when it is factorized. So since we already have a positive x value of like 2 that works out for what we need, we can actually just check if this is factorizable to see if there are potential other options. But I don't think this can be factorized. But let's just find out quickly using the quadratic formula. Minus b plus minus b squared minus 4ac over 2 times a. Yeah, it's giving us a math error. So this here cannot, the rest cannot be factorized. So it means that this is our only valid solution where x is a positive 2. So what that means is where x is a positive 2 here, that's where we have the minimum distance. So what you can do for yourself, if x is a positive 2, the y value has to be a 4. You see, because if you have a 2 here, this y value is going to be a 4. So let's check the distance between this point and 10 coordinate 2. We can just do that using the distance formula. So the distance is going to be equal to square root 2 minus 10, the whole thing squared, 4 minus 2, the whole thing squared also. And then here, this, let's just put it all in the calculator actually. You don't even have to worry about anything. 2 minus 10 squared plus 4 minus 2 squared. That's going to 2 square root of 17. 2 square root of 17. So 2 square root of 17 is the minimum distance between this point here and any point on our parabola. So yeah, this was quite an interesting question. I think it was definitely worth 8 marks. And yeah, the more questions like these you're gonna bump into, I guess it obviously helps in terms of your level of creativity. But obviously for more questions like this, right, which will need you to think outside the box, you can sign up for the online courses on our website. The link to that is in the description. If you need anything, you can always also just hit me up on IG. For now, let's move on to the next question. Okay, so question number 10. What does question number 10 say? Question number 10, we're dealing with the Venn diagram. It says here A, B, and C are 3 events. Yes. The probabilities of these events or any combination of them occurring is given in the Venn diagram. Yeah, you have to remember these are different probabilities. So because these are probabilities, we know that all these numbers have to add up to 1. You see, so we shouldn't forget that, because all numbers in probabilities they add up to 1. It says here, if it is given that the probability that at least one of these events will occur is 0.893, calculate the value of y, the probability that none of these events will occur. So the probability of at least one thing occurring, this is everything in here between A, B, and C. So if they said everything here adds up to 0.893, it means that we can add everything up, remove it from 0.893, and then we're gonna get x. And then obviously once we have x, we'll be able to get y, but we don't even need to do all that actually. No, everything here adds up to 0.893. So we can just say 1 minus this value to get y. So let's do that. 1 minus 0.893. That's what we're getting here. 1 minus 0.893. That's giving us 0.107. There we go. So with x, fortunately, we can actually just say, what can we do for x? X, we can just say 0.893 minus everything here, and we'll be left with x. So let's do that. 0.893 minus all these other numbers here. What are these numbers here? you have here 0.05 minus 0.15 minus 0.05 minus 0.1 minus 0.2 minus 0.183. Okay, what do we have now? Yeah, let's just put all this into the calculator. So obviously in cases like this, you can see that the one thing that will throw you off is not putting these values into the calculator properly. Otherwise, gonna have a problem. You see, let's see 0.2 minus 0.1 minus 0.183. So you're left with 0.16. Yeah, so let's just double check. You have 1, 2, 3, 4, 5, 6 numbers to remove. Let's see here. 1, 2, 3, 4, 5, 6. Yeah. Yeah. So don't think that you're wasting time by double checking properly and all that. Nope. The worst thing you can do is to try and just rush past things. 0.16 is your value of x. It says here determine the probability determine the probability that at least 2 of these events will take place. So the probability that 2 will take place, here's what you do. You take the probability of 2 here taking place, and then, no, that's 3. The probability of 2 taking place, yeah. So if it's only 2 taking place, you have to take the probability of this and this, and then, wait, at least 2. So at least 2 actually includes 3 events taking place as well. So you need to add up this value, this value, this value, and the value in the middle, because this is the probability of these two happening. This is the probability of these two happening. This is the probability of these two happening. This is the probability of everything happening. So if they say the probability of at least 2 happening, it means you have to take the probabilities of 2 happening and then also the probability of 3 of these events occurring together. So 0.1, 0.2, let's see here, 0.1, 0.2, 0.15 plus 0.16. If you add all these up, let's see what you're going to get. 0.1, 0.2, 0.15, 0.16. This is giving us 0.61. 0. Wait. Yeah, no. So yeah, this is correct. 0.61. Let's move on. 10.1.3. Are events A and B independent? Just for your answer. For 5 marks. Wow. Okay. So if the events are independent, it means that the probability of A, right? Wait, if these two events are going to be independent, it means that the probability of B multiplied by the probability of C is equal to the probability of B and C. See, that's for independent events. So the probability of B, let's write that down. Probability of B, you have to remember the probability of B is all these 3, 1, 2, 3, 4. So it's going to be 0.1 plus 0.2 plus 0.183 plus 0.16. Okay, so adding everything up, let's see here. In the calculator, it is giving us, what is it giving us? 0. Say, that's too big. That is, wow, but that's the value we're getting, 0.1, 0.2, 0.183, and then 0.16. Yeah, so that's giving us 0.643. Let's see here, 0.643, 0.643. That's the probability of B. The probability of C, let's see what the probability of C is. It's all these values added up, right? So that's going to be 0.05 plus 0.2 plus 0.15 plus 0.16. There we go. That's giving a total of 0.56, right? So this is 0.56. So we know that individually you have this value times this value. Let's see if it's going to be equal to the probability of B and C. So the probability of B and C, you can put here B and then C here. What is this going to give you? The probability of B and C is what? B and C, the probability of B and C is these two added together, you see, which is going to be 0.16 and 0.2. So that's going to give you 0.3. Let's just write it out. 0.16 plus 0. Is it 0.2? Yeah, 0.16 and 0.2, which is going to give you 0.36. You see? So let's see what you get if you multiply those two figures together. You see, 0.643 multiplied by 0.56. Let's see. If it doesn't give us this value, then it means that these events are not independent. Let's see here, 0.56 equal to, let's see here, this is giving us 0. I guess they are independent. 0.36, 36 what? 36. Yeah, if you round it off to two decimal places, yeah, these events are independent. Therefore, the events are independent. Independent. Dependent. There you go. There you go. The events are independent. So that's that. That was a good question. Worth the 5 marks actually. 10.2. 10.2, let's see. It says here a 4-digit code is required to open a combination lock. The code must be even numbered and may not contain digits 0 or 1. Digits may be repeated. How many possible 4-digit combinations are there to open the lock? Okay, so in a situation like this one, right, let's lay out the kinds of numbers we can possibly have. The kinds of numbers we can have is numbers that start with a 5, and then ones that start with a 6, 7, 8, and 9. So the ones that start with a 5, obviously there's 4 digits to consider. And then the ones that start with 6, also 4 digits in total. Same for the ones that start with 8 and 9. So what I'm trying to say is, right, from the specifications that they told us, okay, so we want to keep in mind that firstly they said these numbers have to be bigger than 5,000. So obviously numbers can only start with a 5, 6, 7, 8, or 9. In a situation like that, it means that one other thing they told us that the third digit has to be a 2. So this has to be a 2, 2, 2, 2, 2. What that means is in this position, one option, right? In this position, one option. One option here, one option there, one option here, one option there, one option here, one option there, one option here, one option there. Now, the key thing is what we already know is if a number is going to start with a 5 and the third number is a 2, automatically it means that 2 values have been used up, right? 2 numbers have been used up. And remember, this is a total of 8 numbers that we can choose from. 8 numbers to choose from, 2 have already been used up. Fine. However, they say the last one has to be an even number. So if the last one has to be an even number, the one thing we know is one even number is used up. So we can only either have 4, 6, or 8 at the end here, which is 3 options to choose from, you see. So once you put a number here, once you put a number there, and once you put a number there, it means 3 numbers are used up. So meaning out of the 8, 3 are used up. So meaning you only have 5 options for this value over there. And then you repeat that process. So here, you can either put a 6, here you can either put a 2, right? So if you put a 6 and a 2 here, here you already only now have either a 4 or a 8 to choose from. So you only have 2 options at the back here. The moment you put 1, 2, and 3 values, you only have 5 numbers left for this position here. For the 7, same idea. 1 number is used up, 1 number is used up, but at the back here, you can either put a 4, a 6, or 8. So that's 3 options. And then here you just have 5 options. Here, 2 even numbers are used up. So here you can only either put 1 of 3 even numbers, which will either be 6. No. 1 of 2 even numbers, bro. You can either put a 6 or a 4. So once you put 3 numbers there, there's 5 options here. You see? And then, so what we also now know is for the 9, same idea here, there's 3 options in total for this part. And then once you put 3 values here, you only have 5 options left. So the total number of combinations, it's obviously going to be 1 times 5 times 1 times 3. Same here, 1 times 5 times 1 times 2. We just have to get these here, and then we just see what we get there. Times. So let's see, 5 times 1, 5 times 3 is like what? 15. Yeah, 1 times 5 times 1 times 2, that's like 5 times 2, that's a 10. 5 times 3, that's a 15. This is 10. This is 15. So all we want to do is to add up all these values, right? 15 plus 10 plus 15 plus 10 plus 15. Let's see what that gives us there. 15, that's like 45 plus the 20 there, that's like 65. So the chances that we're going to have number bigger than 5,000 and the third value is a 2 and it is still going to be an even number, those you only have 65 options like that. It's 65 options like that out of a total of 840. You see, 65 out of a total of 840. Let's see here. 840. 65 divided by 840. Let's see. 840. That's like 13 over 168. So let's see here. 13 over 168. There we go. There you go. This is the probability that the first attempt you have code correct. There's if you want to look at this as a decimal, it's like 0.0074. You see, this is approximately equal to 0.0774. You see, that's the chances of you getting it on your first attempt. So this is quite an interesting question. But yeah, this is what you have to deal with or had to deal with in this kind of a paper. It was quite an interesting paper in my opinion. But anyways, I mean, like, if you need more explanations, more detailed explanations on all the topics that you basically need to learn for your metric year, you can just follow this link in the description. It will take you to our website with all the online courses for your math grade 12 subject. Let me just give an idea of what the website looks like so that we can be on the same page. Let's see here. Where is this thing now? Come on, bro. Come on. Where is this thing? Okay. So if you go to the link in the description, right, you'll see there. Load shedding. You'll see there we have it will take you to the homepage on our website. And then we at this, depending on when you're watching this, right, this is like the all access pass. The all access pass basically gives you access to every topic all in one place for a single fee of just $4.99 monthly. It's not a it is not contract or anything like that, so meaning you can cancel your subscription at any point in time. This is all I can say for now. I will catch you in the next video. If you need to ask me a question via IG, you can do so via this handle here. From my side, I will catch you in the next video.